Now, in terms of shell expansion and regular expressions and all of this like command interpreter stuff, there is a lot more to talk about. I mean, you can imagine that the thing that you use for years and years and years on end has a lot. I mean, it is a labyrinth of functionality. It is crazy. This is kind of an introductory course, so this is really just the basics. Some of this we'll come back to. Some of this is going to be in a 200 level course. But I do think that you should be aware of wildcards and how shell expansion works, and a little bit about regular expressions. Actually, we're going to cover regular expressions a lot more in just a bit, but even beyond this course, I would encourage you to read more about regular expressions because they're pretty handy for searching for things. So regular expressions is a sort of a special term you'll you'll be hearing again and again now that now that it's on your radar. If it wasn't before, you'll hear it everywhere. The next thing that is kind of related to these things to understand is input and output redirection. So when you run the ls program and you do ls-l, the -l is an input, and the output is this stuff that you see on screen. Now I can see that there's not a file here named foo, but if I do an ls, do space foo, it says, oh, ls cannot access foo, no such file or directory. That's an error. So you think of a program, and a program has standard in, std in, sometimes you see it abbreviated as, and then you have standard out, that is the normal output of a program, and then you also have standard error. So you std in, std out, and standard error. And those are numbered in a Unix system, 0, 1, and 2. So 0 is standard in, 1 is standard out, and 2 is standard error. So in the ls program example, we don't really have, I mean, I guess you could say it's not really an input. Normally this would be, we would feed something else to ls. Okay, I'm going to do some scary voodoo black magic, not really. But I've got a file called A that just contains ls-l. And I'm going to do cat. Remember cat, it dumps the files, but I've put it in parentheses and backticks. And so catting the program took the output of A and ran it. And so the output of cat A was ls-l. And so that was sent back to the command interpreter to run the command. But I could also do cat A pipe bash. And so that will take the output of standard out from cat A and redirect that to standard in of bash. That's what the pipe does. The pipe, it's the shift backslash on the American keyboard layout. And so you're mapping the output of one program to the input of another program. Maybe I want to redirect the output of both of those programs to a new file. I'm going to call it B. And so now that has happened. Now let's edit ls-l and say ls-l star foo. Now remember, foo should throw an error, right? So do cat A pipe bash redirected to B. So I get, okay, ls cannot access foo, no such file or directory. And if we less B, we can see that there's a lot of stuff in here. I did a ls of star, and but there's no error in here. There's just the output from ls-l, and it actually looks different. And that's cat A. That's because I changed the command ls-l star foo. So lots of funky stuff going on here. Again, standard in 0, standard out 1, standard error 2. And so let's dissect this command here real quick. We've got standard out and standard error. And if we do ls, pipe B, and we do cat B, we can see that the output of the command went into B, but I get the error on the command line still. Let's run the command again and do 2 to C. Now I got no error on the command line, but we see that there's a C file there. And if I do cat C, it says ls cannot access file, and we do cat B, and there's our output. Now what if I want the error and the output in the same directory? You would do 2 points to B, right? No. If we do ls, if we less the contents of this, we can see no error is listed here. Okay. The astute among you would say, well, every time you run that, it seems to be overriding the file. So if I do bash, cat A type B, I get the error again, and I do cat B. we can see that there's not really anything, it's just the same output over and over again. But if I do ls-b, I can see that the file's modified. Modified pretty recently. Every time you run this command, it's overwriting the file. But if you add an extra symbol, bash is greater than b, then it will add it. And so now if we do an ls-b, we can see, oh, it looks like the output is there twice. So maybe you could do cat a pipe b this, where you get, because we're getting the output, the regular output, but we're not getting the error. So if we ls b, this should have an error in it, right? Nope. It's because you've got to put the input and output back together. You can't do it this way just by convention. It doesn't work. Fortunately, there is a way to send both of them to the same file, and that's ampersand. Ampersand redirect and to B. And so this will send all of standard output and standard error to B. And actually some sophisticated programs can have more than one output. Like program can send an output into more than one place, and so ampersand will capture everything. So there's more than 0, 1, and 2, in other words, in some scenarios, but that's a 200 level topic. Woo! So now we can less B and see, oh, at the top, we've got cannot access foo, no such file or directory, and then we have got our output. And this kind of, this gives us a hint as to why that was not working with the previous command, because look, the error is at the top instead of the bottom. On our ls command, we had star and then foo, and so you would think, well, the shell would expand the star to be all of the files, and foo would be at the end. And so you would think that ls is like, I'm going to go through all of the files, and then it's going to get to foo at the end of the list, and then it's going to say no such file or directory. But here we can see that no such file or directory, the output, the error output occurs before it begins outputting. And that is why, even with the way that we were doing the redirection to add to the end of the file, we were not seeing the output. So now what if we do cat, we go back to one of our earlier commands, maybe we want to have both of these go into B. And actually we'll rm B just to make it empty, and we'll do that, and then we'll less B again. And we can see, yes, ls cannot access foo, no such file or directory, and then we have the output as we expect. The error generation and the output vary from program to program. It just so happens that ls will, give you an error to begin with, but it doesn't necessarily always happen, and that's just because the output is buffered with ls. Some programs, there's a network copy program called rsync, for example, and you might be using rsync to copy files from one system to another, or to synchronize two directory structures between two systems over the network. And those programs generate errors at different times. And so it's still, even though it kind of works by convention, wouldn't recommend it. You should use the ampersand, because the behavior will also be a little different from system to system, and most command interpreters support this kind of thing, but you should really understand that programs that you're interacting with expect to have standard in, standard out, and standard errors, and you should understand what your command interpreter's conventions are for manipulating standard in, standard out, and standard error in order to be able to write complicated, sophisticated things, because this is the beginning. This is the beginning of something really beautiful and kind of magical, in that you string together a whole bunch of simple programs that come up with very complicated behaviors. If you've used PowerShell on Windows, or you've used the command line on Mac, it's born again shell on Mac just the same, then you probably already have it in mind what I'm talking about when I'm saying that you can string together a lot of fairly uncomplicated things to do some really complicated stuff, because managing things from the command line is super involved and super repeatable and super fast when you know what you're doing. It's way, way faster than clicking the mouse around. I mean, the mouse is much clunkier by comparison. Sure, you can stumble your way through without really knowing what's going on with a mouse interface, but if this is your career, you really should learn how to use the command line so that you can do things faster and more efficiently and do more, because that's what's needed. And so we can redirect the output from a program to a file with the greater than symbol. You may be thinking, okay, what about the less than symbol? Well, the less than symbol works pretty much the same way. Remember we've got our A file where I've got ls-l pipe foo, and I've shown you cat a pipe, and we're redirecting the input of one to the output of the other. It turns out most programs are capable of reading a file. The pipe thing really only makes sense when a program is not capable of reading a file. And so bash, for example, the command interpreter is capable of reading a file. And so we can use less than a, and this will tell bash to read the file as standard in, instead of cat taking the contents of a file and putting it on standard out, which is then read as standard in on another program. We're just telling bash to get its standard in from this file. Does that make sense? It's a subtle difference, but it's an important difference, because if your program can read directly from a file or read directly from whatever, generally passing it through cat with a pipe will slow things down. Generally, you want the program to be able to read from the file if it's capable of reading from a file. And you may not even need less than to dump a file into a program's standard input. So we could do bash less than a output to b, and we get the same sort of output. ls cannot access directory, no such file or directory. And if we less b, we can see that b contains all of our stuff. And if we do ls, we less b again, we can see that we've got 2 instances of that now. Everything really just works the same. So I can do cat a, you can also do cat a pipe bash. But this is not considered as good of a form for doing this kind of thing. You can also do something like this, where you've got a, and then some command is going to be bash. And so it's running the output here, and then you could say, B. Same kind of thing. A little subtle difference there as well, but hopefully if you get the mental picture of a program having standard input and that program having standard output, but also forking and having a standard error as well, you're sort of kind of beginning to understand input-output redirection. And so to recap, the things that you should understand: greater than, less than, double greater than, double less than, ampersand greater than, pipe. You should know off the top of your head what all of those does. And if not, rewatch on slow. Because I know you're going through the course at 2x. I can see it. That's fine. I do too. I do that too. I mean, it's just like, stop talking, read, let's just get through this. And then it's like, wait, there's something really crazy happening here. I can feel neurons like forming new links, like, I don't know, axons moving around and linking up, and chemical pathways and crazy stuff. This is another one of those things where it looks really simple, and it is pretty much really simple, but having a good mechanical understanding of it is really important for the next stuff.